Hi everyone. We're going to start a new series of videos to do with polynomials. Okay, and this first set of videos will be sort of an introduction to what a polynomial is and how we can work with them. So, basically, a polynomial is a general name that we give to a broad class of equations. Okay, and these equations all have a similar form, and that is as follows. Okay, so this might look like gibberish to you, but we'll talk about what it all means. So it's basically just a bunch of terms. Here we've got a term, and you've got all these terms in between, and you've got a few more terms sort of at the end here. Okay, let's look at what all these terms look like. So we'll start on the left. We'll start on the right. So we've got this term here, which we call a0. It is not multiplying a variable of any kind. It is simply just what you might call a constant. Okay, and in fact, we give this term a name and we call it a constant term. It's the term that doesn't have a variable in it. All right, and as we go up the list of terms, notice that every time we add a new term, okay, we also increase the power of our variable. In this case, our variable is x. So the next term along has the variable x to the power of 1, and it's being multiplied by some other coefficient, which may or may not be the same as the constant term. And you can keep going. You add another term to this growing list, and notice we increase the power of our variable by 1, so it turns into a 2, and that's being multiplied by some coefficient, which may or may not be the same as a1 or a0. Okay, they could all be different. And you keep doing this, and you keep building up this expression by increasing the power of x each time you add a new term. And you can do this for as long as you like. You can stop whenever you like. And the term that you stop at has the highest power or the highest index of your variable, and we're just labeling that with an n here. Okay, so let me write a few down and you'll see what I mean. So we could have a polynomial, let's just call it 3x squared plus x minus 1. Okay, that's a quadratic of some kind. And notice it follows this pattern. You've got a constant term here, in this case it's negative 1, followed by another term, which is just 1 times x, followed by another term, which is 3 times x squared. Okay, this is a polynomial. It's a quadratic polynomial. Okay, we can also make them a bit more varied. So let's call this one 4 times x to the power of, negative 4 times x to the power of 4 plus 71x to the power of 3 minus 18x squared plus 2. Okay? Now actually I'm going to write the plus 2 with a bit of a gap from the others, and you'll see why in a second. Okay, so let's just see, yes, this is a polynomial. We've got this constant term here, positive 2. Our next term, which would just be multiplied with the x, well, there is nothing there. So you could consider this to be almost like saying plus 0x. Okay, it's got a coefficient of 0, so you don't technically have to write it down, but you could still put it there if you wanted to, and it's not going to affect the way that you write down this particular polynomial. All right, and then you can keep going. We build up the next term, so that's negative 18x squared, increasing the power of x as we go along. Here we've got 71x to the power of 3, and that's negative 4x to the power of 4. So this whole thing, as one unit, is a polynomial. Okay? So don't worry too much about the terminology that's on this slide. Okay, that's just the general way to express any kind of polynomial imaginable. Okay, the important thing is that we're always using whole numbered powers. Okay, so 0, 1, 2, 3, 4, and we're not using negative numbered powers. Okay, cool. So that's polynomials. Just some more terminology. Okay, so the leading term, what we call the leading term, is the term with the highest power of x, or if you prefer, the highest index of x. Okay, so we've got some examples here. So we'll call this first one p of x, and you'll notice it's very similar to function notation. So instead of f of x, usually for polynomials in general, we would just call them p of x, q of x, r of x, whatever of x. This p of x is equal to 3x to the power of 4 minus 2x to the power of 3 plus 18x squared minus 100x plus 5. Now you look at the term that has the highest power of x. Okay, in this case, it's this first one over here. And so that's our leading term. Okay, because there's no other term that has a power of x that is higher than that. In the next example, we've got q of x. Okay, and this is equal to 1 minus 55x cubed plus 18x minus 22x squared. In this case, the terms are all jumbled about. They're not in the order that we've seen them just before. And that's fine. We're allowed to do that. But in this case, the term that has the highest power of x is negative 55x to the power of 3, or x cubed. Okay, and just be really careful that you include the negative signs. Okay, they're always attached to the thing that comes after it. So in this case, our leading term is negative 55x cubed. Okay, and just again, when you write polynomials, normally, and this is the way you'll see them written 90% of the time, they go in decreasing powers of x. Okay, the terms go down in powers of x one at a time. Okay, starting from the left, going to the right. So you usually see them written in the way that we've written p here, but there's no reason why you have to do that. Okay, you can write the terms in any order you like. Okay, it's up to you. It's up to the question. All right, so a bit of terminology, leading term. Another bit of terminology is the degree of the polynomial. Okay, and this is the value of the index of the leading term. Okay, so these polynomials in these examples, it's the same as the last slide. We saw that the leading term for p was 3x to the power of 4. So that means the degree of this polynomial is 4, because that's what the power of the leading term is. Same thing for q. We saw that the leading term was negative 55x cubed. And so we say the degree of this particular polynomial is 3, because that's the power of the leading term. Okay? Now, linear equations, which are a type of polynomial, okay, that's just going to be of the form ax plus b. Okay? They always have a degree of 1, because the leading term is just the term that has the x in it, and that's technically x to the power of 1. Quadratics, you can do the same thing, ax squared plus bx plus c. Okay, that will have a degree of 2, because that's just what the power is of your leading term. Okay. Later on, we'll see cubics, which have the form ax cubed plus bx plus c, plus bx squared plus cx plus d. They have a degree of 3, and so on and so on and so on. You can keep building them up. We don't really have names for things after degree 4. So degree 4 would be a quartic. After that, we don't really have a name for them. You just would call them degree of 5, degree of 6, degree of 7, and so on. Okay? All right, more terminology. So we call a monic polynomial any one in which the coefficient of the leading term is 1. Okay? So here we've got some examples. These are different from the ones we had before. So if we look at p of x, it's equal to x to the power of 4 minus 2x squared plus 9. The leading term of this, remember the one that has the highest power, is x to the power of 4. What's the coefficient of that leading term? Well, because we haven't written a number in front of it, it's assumed to be 1. That's just the convention. And so we say that this is a monic polynomial because it has a leading term coefficient of 1. Whereas with q of x, if you look at the leading term, it's 2x to the power of 5. It's not monic because its coefficient is not 1. In fact, is 2 in this case. And we can say that this polynomial is non-monic. Okay, so monic polynomials have a leading term whose coefficient is 1. Right, now as I said before, it's got very similar notation to functions. So we're calling this polynomial p of x, and you can treat it the same way that you would treat a normal function of any kind. Okay, so with this notation, what we can do is I can replace the x here with a number or some variable expression, and I'm going to replace all of the x's in my polynomial with that number that's in the brackets there, just like we do with functions. Okay, so let's test that out with these examples. So we've got p of 1. That just means replace the x with a 1. Okay, so in this case, we're going to have 1 to the power of 4 minus 3 times 1 to the power of 3 minus 2. Okay, 1 to the power of 4 is 1. Minus 3 times 1 to the power of 3. Well, 1 to the power of 3 is 1, and 3 times 1 is 3, so it's minus 3, minus 2, and you end up getting negative 4. Okay, cool. Next one. So p of negative 1, well, you just replace the x's with negative 1. So we're going to have negative 1, and it's customary to put negative numbers in brackets when you're doing them to a power of something, because that way it removes any confusion whether or not that negative is attached to the number or if it's outside of your exponentiation. Okay, so in this case we're doing negative 1 to the power of 4, so you put the negative 1 in brackets and do minus 3 times negative 1 to the power of 3 minus 2. Okay, so negative 1 to the power of 4, if you do it yourself, negative 1 times negative 1 times negative 1 times negative 1, you end up with positive 1, minus 3 times negative 1 to the power of 3. Now, negative 1 to the power of 3 gives you back negative 1. So really, we've got minus 3 times negative 1, which is plus 3. So we write plus 3 minus 2, and that gives you 2. Okay. I'm going to leave the other ones because you could do them yourself. You can see it's very similar to how you work with functions. Okay, you just input this number here or this value here and replace that for the variables in the expression of your polynomial. And then you just evaluate it using your arithmetic skills. Okay, so I'll leave those two for you guys to do yourself. That's it. That's it for this video. So just introduced polynomials, some terminology involved with polynomials. So leading term, constant term, degree, monic, stuff like that. Okay, and we also saw how we can evaluate polynomials at a particular value by just substituting the variable with whatever value you like. Okay, and that's pretty much it for this video. So we'll stop there, and I'll see you next time.